Hello, this is K2 Concept YouTube channel, and with you is Dave Kome. And today on this video I will be taking you on another rule of differentiating known as the chain rule. In my previous video I explained how to use the product rule and the quotient rule. So today we are going to be going into the third rule of obtaining derivative of any function, which is known as chain rule. Now, anytime we see a problem of this kind, it is known as a chain rule problem. Now, to go further, let me explain problems that we can tell that they are what? Chain rule. Example of such problems are problems of this form: 2x squared plus 5x all squared. Now, why is this problem a chain rule problem? Remember in my previous video, that's my first video, we explained that this problem here, or this function, is known as what? A power function. But now we can see that a power function having a power, anytime we encounter problems like this, the only way we can differentiate this problem is to apply the what? The chain rule. And also, we know that in the table of standard derivative, what we have is sine x. So anytime we have any other external thing attached to this x, that is x squared, 2x plus 5, and so on and so forth, then the problem also is a chain rule problem. How do you solve? The selection of u is very important. If you can't select your u appropriately, then you can't solve the problem. So take note, your g of x is usually selected as u. Your g of x is usually selected as u. Then you differentiate. So we are saying that the formula for the chain rule is dy dx equals to dy du multiplied by du dx. This is the formula for chain rule. And now we're going to look at 4 examples to illustrate the chain rule. The first one is 3x plus 5 squared. Now this is a power function that resulted in what? A chain rule problem. Because a power function having a power or having a root, we said it is what? A chain rule problem. And the first thing to do, if I'm to compare this problem with what we are having here, my g of x is a 3x plus 5. Then my f is this power. So it's saying the g of x is a function of this power. So the first thing you have to do is say let u equal to g of x. That's the first thing you do. And what's our g of x? Our g of x here is 3x plus 5. Then automatically, if u equal to g of x, then our y equal to what? F of u. And what is our u? Our u is this. That's f of u, or what? Square. F of u. So the next thing you have to do is to differentiate the u with respect to x and your y with respect to what? U. So I'm going to have du dx. We have explained how to differentiate a power function. We said this will result to 3. Then if you differentiate the y with respect to u, this will result to 2u2 minus 1, which is what? 2u. Now the next thing is to apply the formula. The formula says dy dx equals to the y du times the u dx. And what is the y du? As is 2u multiplied by du dx is 3. And we know that these two are constant function. So 2 multiplied by 3 will give us what? 6. Then we are left with what? U. And u from the question is 3x plus 5. And that is the derivative of this problem. The second one is y equal to sine 2x. And the next thing we are going to do here is to select our u. To select our u, and I said our u is a g of x. And what's our g of x here? Our g of x is this 2x. So it means u equal to g of x, which is equal to 2x. Then if this is our u, the next thing is y will be sine of u, that is the function of u, that's sine of u. Then the next thing is to differentiate your u, the u, the x. If I differentiate 2x, I will obtain 2. And if we differentiate sine u, it's just like differentiating sine x. From our knowledge of standard derivative table, we said the result of dy du will now give us what? Cos u. Then we apply the formula, which is dy dx equal to dy du times the u dx. Then what is our dy du? To give us cos u multiplied by du dx will give us 2. And we said if you have a problem like this, there's an arrangement pattern. We said sine, that's plus or minus, comes first, followed by constant, followed by the power function, then followed by the exponential, the logarithm, and the trig. So the constant will come before the trig. So it becomes this, then you replace your u. And our u for this problem is 2x. Now the third question. The third question is y equal to 5x minus 1 as 5x squared minus 1. Now, the first thing to apply the chain as being stated earlier is to identify the u. And we know that the u is our g of x. And for this problem, this is our g of x. For an exponential problem resulting to chain u, this is always our u. For a trigonometry function, this is always our u for this case. So it means our u equal to 5x squared minus 1, which is the same thing as your what? Your g of x, don't forget. So it means y will now become e of u, that is function of u. Then the u over the x will give us 10x. Then the y over the u will give us exponential u. It was obtained from table of standard derivative. Then we apply the formula dy dx equal to dy du times the u dx. Now dy du is exponential u times the u dx is 10x. Arranging this from the knowledge of what was explained in the first video or video on product 2. If you have not watched this, try and do so. We have 10x exponential u. Then our u, we know the value of our u. Our u is 5x squared minus 1. It must be replaced. In the last example is also a chain rule problem involving a trigonometry function, just like the second problem. But there's a difference here. This problem here can be written in this form, cos x all squared. It's the same thing. So with this, you will see the chain rule problem. But like this, it is very difficult to understand that this problem is a chain until you transform it to this form. So from here, we can easily see that this problem is just like the first one we just solved. So our u is equal to g of x, which is equal to what? Cos x. Then our y will become u squared, which is the u dx will give us minus sine x. Then the y, the u will give us 2u. Applying the formula, the y dx equal to the y du times the u dx. And what's our dy du? It is 2u multiplied by du dx is minus sine x. Arranging this one, the minus sign will come before the constant from the arrangement pattern being explained in the first video. So here will give us minus 2u sine x. Now when we place our u, what's our u? Our u is cos. So it becomes 2 minus 2 cos x sine x. Now, I have successfully explained how to use the chain rule to obtain derivative when we have a power function, a trigonometry, and an exponential function. Thank you for joining me today, but please do not forget to subscribe, like, comment, and at the end, share to others so that they can also enjoy this. Thank you.